Well, what can an FTIR do? Here's just an example of just two FTIRs that I have. There's a PerkinElmer Spectrum 2 and a Thermo IS5, which now they are older instruments of the newer ones that are out there now. But what can an FTIR do? It really can only do transmission analysis. That's what originally they did. They made everything with molds and KBR pellets. And whatever you could put in the beam, you were able to analyze quite nicely. But to get more out of your instrument, you really need to put something in there that is going to get you the data that you need. You need an accessory. We're going to talk about a bunch of different accessories today. But using the proper accessory to get the data that you need easy and fast and accurate is essential. So you need to be able to get the data that you need, the correct information to be obtained. So the first question I ask is, what is your sample? Plain and simple. What is it? Solid, liquid, a gas? We can analyze all of them. It all depends on what you need from that sample. And how many do you have? Do you have just a couple of them? We only have to do a couple a day, or I got 20 or 30 a day I need to do. I need them to do them 24 hours a day, 7 days a week. It all depends on what you need to do. So is it a couple of them or a lot of them? Then the next question is, what type of data do you need? Do you just need to get, what is this, that bulk characterization of it? Or do you need the minor components in there, like an additive in an oil, or just the surface of the analysis? I just need to get that top coating. I just need to know what that spot is. Or do we need the bulk, the penetration? You need to get into the sample to really find out what it is. And then you can always do quantitative analysis. But there's other things that you want to consider. Do you need to heat up your sample? Do you need to put it under pressure? Or do you need to put it under pressure and temperature? There's accessories for all of those. So here's some questions, and the answers are the accessories. What's my final product made of? You can do that by ATR or transmission. Very easily done. I got this spot. I'm making this polymer film, and all of a sudden I got this blemish on there, or this black particle in there. And there you can analyze it. Just if it's a nice blemish, if it's on the surface, an ATR can do that. And whether you're using a regular ATR or one from a microscope, which the microscope here in the picture down in the lower right-hand corner does have an ATR on it. Incoming product. I have a reaction that I need, and I got a trailer load, or I got a train car out there. I need to test that to make sure that my incoming raw material is what I ordered. Doing that by ATR is very quick, or transmission is very quick. Now I made my product. Is it finished? Did I get the product that I was looking for? Are all the reactants gone with that? Or if they're not, did I do my measurements correctly? Is there an imbalance? I have a sample that is small. Going back to that little speck that's in my polymer film, how do I get to look at that? I can pick it out, put it on a compression cell, and do a transmission analysis, or I can put the speck on a slide and do an ATR with the microscope, but you could do things that are very tiny. I got a big piece of sample. I just take it, put it on the ATR, or cut a piece, make a transmission of it. So what can you analyze? Here's just a small list of different solids, liquids, and gases. And boy, that took a long time to load up. Paste, gels, drugs, going into gases. Explosives, you can do the raw explosive or the gases from the explosives, toxic gases, fibers, air sensitive samples. A lot can be analyzed. It covers a wide variety of samples that can be worked with. So what are the FTIR accessories? ATR, transmission, diffuse reflectance, also specular reflectance. That should just be reflectance accessories. Gas cells in microscopes. Sample preparation. To make that KBR pellet, you need a press and a die to do that with. I need a thin film made out of a polymer. You need a filmmaker to work with that. Polarizers. I got something that if I polarize it one way, I'm going to get one piece of data. If I do a 90-degree from that, I can get my S&P polarizations from that. We have polarizers. And then process cells. I have a stream that's coming in, and I need to analyze that constantly, from a reaction stream. We're not going to be talking today about polarizers or process cells today. That will be in a future webinar. Now, almost all the spectrometers in the market will fit our accessories. There's only a couple of them. They are the very small FTIR models that are out there. And obviously the handhelds, FTIRs, you can't use an accessory with that. So the most common FTIR is an ATR, attenuated total reflectance. And here are three that are examples from SpecAc. The Golden Gate has been a stronghold of a diamond ATR, probably 25, close to 30 years now. It has been on the market for a long time. I just was talking with a customer the other day who's had one for over 25 years, and it is still working for them. They just wanted to see if they needed to get it tuned up. So let's look at that bulk characterization with an ATR. Here's a water-based adhesive. This is a customer sample, and I have permission to use their data. I can't say what it is, but it's a water-based adhesive. Now, this is just taken and placed on the ATR. It's a very nice spectrum, but they're looking at minor components in this, and we're going to get to that a little bit further. So you'll see this spectra again. But a bulk characterization. All I do is just take some oil, some 5W30, placed it on the ATR, hit the scan. Now, if I wanted to do minor components, which are up in this area, I'd go to a different technique. And that would be a transmission with bigger path lengths. You'll see something like that, very similar coming up. Anybody hungry and have something to eat at lunchtime and you just so happen to have potato chips, and they just happen to be barbecue potato chips? I had that one day, and I'm sitting there eating potato chips. I said, this could be pretty neat to take a look at. I just took it, put it on the ATR, put the pressure device down on it, hit scan, and I thought it was pretty cool. I didn't go any further than that. I didn't go bother to analyze it and looking for the oils and everything else that's in there. But I thought it was just pretty cool. So here's a hard sample to analyze. I wanted to take a look at the analgesic pill. This is acetaminophen. And I wanted to look at the surface of it, because most tablets you get, analgesics and a lot of pharmaceuticals, are coated with something so they don't taste nasty. But I wanted to take a look at that coating, and there's really two ways of doing it. One is, and I did it both ways, which I went under a microscope, a stereoscope, and very tediously peeled off the coating to do an analysis. I didn't do that here. This was done by an ATR. And you got to be careful, number one, to get it on the ATR crystal. And number two, you don't put too much pressure on it. You just need enough pressure to get a good sample, which I did get here. But then if you take and you go down below, here's where I crushed it up. And I was looking actually at the acetaminophen. It says coating there, but that's actually inside the bulk. All right, why the slide didn't change? There we go. Transmission analysis. What can you do with that? Liquids and solids. Quite easily done. Well, the computer's playing with me now. So you could look at that for either bulk analysis or minor components. We're going to be looking at both of them. So here are transmission cells. The Omni cell, that is the standard transmission cell that has been on the market, probably 60, 70, 80 years since the beginning of dispersive infrared. The Pearl is the newest addition to a transmission accessory. Advanced, this has a lot more. You can heat these up, variable path length. And then if you go to high pressure, like 2,000 or 5,000 PSI, there's stuff you can do with that one. So let's have something that is very viscous that might not be easily put into that Omni cell. Here's a different cell, the Pearl. And you're able to put white lithium grease in there very easy and be able to get very good data. This was at 25 microns. Let's go back to that 5W20 motor oil. This was done, same path length, 25 microns, put it on there. Nice thing about this accessory is that grease and the oil are tough to clean up. Now, with the Pearl, you're able to separate out what we call the oysters. Yes, the oyster is on the inside of the Pearl, not the other way around. I didn't have a chance to name the accessory. That was done before my time. I'll show you the oysters in a little bit, but you can separate those out, which is great because then you can really clean it up. You take and you wipe off the grease with a cotton swab. First off to get the bulk off, then go in with a solvent that will remove the oils or the grease or whatever you're doing. You can even use water, alcohols, whatever is going to be convenient. Something I did quite a while ago is I wanted to take a look at another transmission type accessory, white PVC pipe. As you can see, you have the PVC pipes here. Look a lot like fittings to plumbing fittings. That's exactly what they are. So I took in, I did that, and I did it by thin film. I used one of our thin film makers, put the piece of PVC in there, squished it down to about 25 microns, did a good transmission of it. I wanted to take a look, and I did a search of the PVC library, and it came up with PVC. Now, they don't look exactly alike because I ask this question when I do my other seminars. Why is that? And it's because there's a lot of things in here. This is pure polyvinyl chloride. This is not. There's probably UV inhibitors in there, probably a lot of titanium dioxide in there, other binders and things that changed what the spectra looks like. But that is another analysis that can be done, and you can get good results on it. And where did I get all the fittings? Well, I redid my bathroom, and all the fittings were, you can't see them now because they're all behind here. Minor components in transmission. Remember that water-based adhesive we had a little while ago? So we did it by transmission using the Pearl, and we put it at 25 micron path length, and we got this pretty good spectra. Obviously, the bands here are way off. They're highly absorbing. But my customer didn't care about these, did not care about these. They were looking over here. So let's look at different path lengths. This was 25, 50, 100, and 200. That's what they were looking at. So let's take a better look at that. And here it is. They were very interested in the analysis here at 200 microns. And they were even thinking, well, maybe we should go to 500 microns. And they decided, well, if we need that, we'll buy it, just buy the extra Pearl, the oyster rather, because you can just take and swap these out very easily. And this is just, the region is 1800 to 2500. That's what they were looking for. They were very happy with what was going on there. These right here are the oysters. You have a bottom oyster and a top oyster, and you get your different path lengths by changing this bottom oyster. So when you get the path lengths, here's 3 different ones. The black is 25, the red is 50, and the blue is the 100 micron. And you can see differences in here. If you're looking for minor components, you're going to want to go up to the higher path lengths. If you have a bulk analysis, all you need is the, the 25 micron. So transmissions versus ATR. Here we're looking at the Pearl is transmission accessory. The Quest is the ATR in blue. And you can see the differences. These are the exact same motor oil sample on the same scale. And it depends on what you're looking for. That's how you pick your accessory. Do I need just a bulk analysis of it? I can use the ATR and get my bulk analysis as you saw, but I need to get down in this fingerprint region and these very tiny little additives I have for the oil. So that's what you would go for. It's all what you're looking for. It's the sample that it's going to depict the accessory you're looking for. So let's look at a couple different areas. Time studies and heat changes with the heat. So here's another ATR. This is a removable ATR. It's called the Arrow. It goes on the Quest. Do you need to have an analysis for a long period of time? Hours, days, weeks? And if you had this on a regular ATR, you would tie up the ATR for a very long time. This is where this removable comes in. You can set up several of these arrows. They just slide into place quite easily. They work quite well. There are customers out there that are using hundreds of these a month for their studies. Nice thing about it is they're disposable. They're not that expensive compared to a diamond ATR. And you could take these, set up a series of samples. Like if you're going to do adhesives, which I'm going to show you an example of an adhesive here over a period of time that you cannot take and tie up the accessory or the instrument for. And you're able to take this and put it on the side. And it works great for that. Or if you want to be able to have that stored, you can you put your sample in here, you could put a cap on it and put it on the side. And you can have that for further use. Here's the an adhesive. It's curing over time. And as time increases, the bands, this is the isocyanate band, is decreasing with time. And this doesn't happen immediately. This takes a while for this to happen. So it was taken over a period of a couple hours for that isocyanate band to come right down. It starts off probably pretty quick, and then this is over, the last bit of time there. And nice thing about it is you have an accessory like the Quest with the Arrow combination to be able to do this and free up your bench for other processes. Let's heat something up. I'm sure everybody uses butter or margarine, and it's basically an oil and water suspension. So we took some butter, put it on the heated puck, and this is all the data we collected. And you can see the blues are at the lower stages, and the red, as it gets hot, you could see the data is changing. And we just looked at that as the solid phase and the oil phase and the changes with that. So if we take that and plot that out, we plotted out just two different wave numbers. And you can see as the oil is there and it melts, the water comes down because oil floats. As the water evaporates and goes off, the oil comes back down. So you see that. The only difference between these two is we used a lot of butter here. We didn't use as much butter here. So there was a lot less. So what we did there is this went faster, is what I'm just demonstrating there. We also did another temperature study. We did this with the Golden Gate, which we had to get a sample. Somebody said, let's go get some dirt. So we put the soil on there, and the top spectrum is at room temperature, 25 degrees. And we started heating it up and taking data every so often. And when you get down to about 90 degrees, pretty much the water is gone. And you wind up get SiO bands right here, the silicon dioxide, or SiO2. So now, switching to those small samples we talked about earlier, we have polyethylene terephthalate ester. And this is in a fiber. And we were looking at the fiber, and we looked at it in two different ways, one by transmission and one by ATR. And you can see that they are very, very closely matched. So how do we do the transmission? You can see these are the actual photos of the fiber. And this one looks different because what we had to do is we flattened the fiber out so we didn't have a round surface. It was flat so we can really get good transmission going through the fiber. And with the ATR, you can take and just touch the fiber and get a good spectrum. Now, if you take and go down to, this was actually taken out of the famous river over in New York, and took a 5-gallon bucket out of the Hudson River, poured it through a filter to see what was there. And we found this tiny little particle here, this white, clear, looks like a polymer of some sort. We took that as the Hudson white particle, number 3, because there was others. Did a really nice transmission of that, matched it up with a library match of polyethylene. It's a medium density, and it looks very nice. And you can get a very good idea of what is there. Now that could be, remember I was talking about that polymer film that that companies produce that had a little black speck in it. You can take that black speck, and this could be the black speck that was in there. And you can find out, geez, all of a sudden we have a piece of rubber in our material. Why is that? We did a little analysis of that, and we found out that earlier in the process, an O-ring broke down, fell off, and dropped into the polymer, and it came out. And we found out, oh, that's what it is. We found out that there was a problem earlier in our process that we had to correct. And they were able to save a whole batch of polymer that they were working with by just one little O-ring they were able to find. Going on to gas analysis. People use that all the time. We have cells that are like 10 centimeters, and going on to the bigger cells that go up to 20 meters. Different varieties. These are the Cyclone, that's the Typhoon, Atmos. Windows, we settled on calcium fluoride and zinc selenide because number one, they're non-hydroscopic. They're not going to break down, and they'll tolerate the heat. There are heating jackets that go on these. The Cyclone can be either in a glass, like you're looking at here, or it can be metal, which you would need the metal for the heating jacket. You need that variety of it. So, came up that we were working on this, and somebody asked, what can we do to test the gas cell? And somebody said, let's use some car exhaust. So they just went up to the cars, did a couple different cars. Here's a petrol engine that was done in the UK. So I'd call it gasoline. Same car, 2002, when it was cold and it was a hot engine, you could see there's difference in the alkenes that are there, difference in the stretch and the carbon monoxide area. Looking at the a different engine at a cold start, those match up pretty good. And then a diesel, two different diesel engines, whether it was 2014 or 2010. And nice thing about it is it was an easy experiment to do. We just pulled a little vacuum on a gas cell, went to the exhaust, opened up the valve, sucked in the gas, and put it back into the FTIR and took the analysis. Quite easily done, quite nice. We have some stuff that is research accessories. Now, the caveat here is we produce these great accessories for research, and it's hard to get data from it. You know, I have these are installed in universities, and NASA has one of each of these, and you're not going to get anything from NASA, but we did get some data from these. As we slide that over to high pressure, high temperature cell, high temperature, high pressure cell, 800 degrees C and 1000 PSI. Neat thing about this, you can do several different things with it. You can do a straight transmission, put a pellet in there, do a straight transmission in there. Decomposition, there's a pan on the bottom so you can heat a sample up and look at all the gases coming off. And then there's another accessory that you put in there, an attachment that you can do specular reflectance from. But we're just going to look at some coal, where the coal was taken, put in the pan, and it was no, this was a pellet that they took and looked at. And this is a lot of data that was collected over a period of time, over temperature, and the absorbance values. And you can see this really nice peak coming up and then dropping down. And that was taken right here at the 1786 peak here. And the black is when you first start, and as you heat up, things change. And you can see a growth rate of the peak that was here. It's a little hard to see in this. I wish I had it. I wish I had this blown up better. And then you get to the point here where it starts to ignite and burns, and then there's a big change from here to the ignition point here, and then after it burns, everything goes away. There's a lot you can do with this. There is a tremendous amount of data there that you can collect with this accessory, with the high pressure, high temperature cell. It works quite well. I wish I was able to get more data on it. It's really neat to work on. It's really cool. The variable temperature cell ranges from minus 190 to 250. That's cold. You know, to get down to that temperature, you're using liquid nitrogen. So you can do tests with liquids and solids. Now, when you go to Raman and fluorescence, you need the blue chamber to be different. This here is the 2-port version, a straight through version, which is what this is set up for. For the Raman and the fluorescence, there's a 4-port, so you have windows on all 4 sides. And then there's a holder here for a different cell, which you would put in for like a 1 centimeter transmission cell for like UV, that quartz cuvette, basically. So if we looked at this, and we looked at the thermal runaway of germanium, we use germanium for an ATR crystal. And if anybody's ever used it, they know if germanium starts to heat up, it goes infrared black and you don't get anything. And you could see that here as you're heating it up, your transmission values, instead of going down to 400 at 250, you're at 1500, you get down to 0, and your transmission is, maybe 5%. Really unusable up that. But what you're showing here is you're able to take an accessory, take a sample, and get the data through temperature. Quite easily done. That was a lot about a lot of accessories, and I hope you enjoyed all that. With SpecEc, we design and manufacture accessories and sample preparation equipment for infrared, XRF, and near IR. The near IR process, that's that process cell. We have a brand new building in Orpington, Kent. This was purposely built. Brand new. The facility is wonderful. And we are in the Fort Washington on Commerce Drive, 414, obviously, Commerce Drive. We occupy this bottom space here. So the biggest thing I want you to remember is that it's the sample that depicts the accessory. Just because you have an ATR in or a transmission accessory or another one of the accessories there doesn't mean you're going to get the data that you want. It's the accessory that is going to pick it's the sample that picks the accessory to get the data that you need. Well, I hope you enjoyed everything. And who has questions for me? And
so I'd just like to interject there and say thank you very much, Jeff. That was a very informative and interesting presentation. And if anybody does have questions for Jeff, there's a little Q&A feature that you can get access to. There's a button for it at the bottom of your screen and also on the left-hand side where you can ask any questions, and we'll do our best to answer here on the call. But if not, of course, please do email Jeff, jeff.d'agostino@specat.com, or get in touch with someone else at SpecEc if you have their details. We'd be more than happy to answer your questions.
Yeah, like I said, I answer the phone and I answer email. And you're welcome, Omar. Omar said thank you. I'm here. I'll be here for a couple more minutes. If anybody wants to post anything, please do. I don't know if we can go turn the microphones back on. Will, I don't know if you can do that. Okay. Will, is there anybody in attendance now? We had quite a few people here, and I appreciate having everybody here.
Yeah, we still do have a few people on the call.
Yeah, there's 20 left. And anybody have any questions?
Hi, Omar. Yes, you will be sent a recording of this session in a few minutes' time.
Yeah. I believe we are going to be posting it on our website or on YouTube. We have a YouTube channel also.
That's correct.
Thank you for the interesting webinar. You're welcome, Fatima. Plans for focused webinars on gas or just ATRs? Yes, we will be looking into that in the future. We're going to probably be doing a webinar. I don't know the frequency, but we will definitely be putting them up. They will be put out there that you'll have access to. Andreas, you're welcome. And also I'm also thinking about doing things on, you know, other specific techniques, even going back to like making the KBR pellet or really working on a transmission cell and getting more detailed in that, and definitely detailed into the ATRs. I also participate in doing a workshop at the major um, trade shows that specifically are on really bad spectra and how to correct them. It's a really good workshop. We have a lot of people. We do actually even do a live demonstration and working on getting the next one at the SciEx conference. That'll be out in Nevada, uh, near Reno. And also we do it at the Eastern Analytical Symposium, and that's in like October, November timeframe.
Okay, everyone. Well, if there are no more questions, I think we'll go ahead and we'll close out the session. Thanks again to everybody who's joined, and we look forward to seeing you for the next one.
Excellent. Thank you very much. I enjoyed this. Have a great day. Thank you.